Good morning. Today we are going to see the problems which are related with your unit test 1. So now we have first problem, that is find design. Calculate the tensile strength due to rupture of single angle section ISA 100-108 at 12.1 kg per meter connected to the gusset plate by 6 bolt of 16 diameter. So now in this, we have to find only a strain due to rupture at critical section. So read question carefully and then start to solve it. So now we have properties of this section not required in this problem. We will directdirectly go with P, pitch, because what is required, you can write the formula TDN is equal to 0.9 ANC Fu upon gamma ml plus beta AGO Fy upon gamma m. So we will find one by one terms. So we will first go with ANC. So we have ANC, that is net area of connected leg, will be D minus T by 2 minus N into DH into T. And then by substituting value, we have as both 100, so we can take any one 100 minus 8 by 2 minus single line of bolt into DH is diameter of hole. So we have 16 plus 2, 18 into 8, and we have value of A and C, that is equal to 624 square. Now go to AGO. So we have AGO equal to now B minus T by 2 into T. Now here we have 100 minus 8 by 2 into 8, and we have this value 768 square. Now we have to find value of beta. We have formula for beta 1.4 minus 0.076 in bracket W by T into Fy upon Fu into Bs upon Lc. Now we will go one by one terms. Now we have W, so that is outstanding leg, we have equal to 100 millimeters. T, we have thickness 8 millimeters. Now BS we have W plus WT minus T. Now WT already I mentioned, you have to go with 0.5 to 2.57 into dimension of leg, which is 100. So which comes 52 to 57. So you can take this value WT equal to 55 millimeters. So if we will put here, then we will get value of BS, which will be equal to BS equal to 100 plus 55 minus 8, and we will get this value 147 millimeters. Now LC, we have length of connection. So now for length of connection, we require P. So we will find P. So P we have 2.5 into D, diameter of bolt. So we have 2.5, diameter of bolt is 16. It comes 40 millimeters. So let us provide higher than this. Provide pitch 40, 50 millimeters. You can take 40 also, no problem. So pitch 40 millimeters. Then what will be LC, length of connection? So we have how many boards? So given 6 boards. So 1, 2, 3, 4, 5, and 6. So distance between these boards, that will be your LC. Now we have pitch 50. So we have 50. So 1, 2, 3, 4, 5, and therefore we will get LC equal to 250 millimeters. And now substitute values in the equation of beta. So we have beta equal to 1.4 minus 0.076, W we have 100, T we have 8, in bracket FY 250, FU 410, BS we have 147, and LC we have 250. And by substituting this value, we have value of beta that is equal to 1.12 something. So I have taken it as 1.13. And now put all these values in the equation of TDN. zero point 0.9, ANC we have 624, into FU we have 410, gamma ML we have 1.25, plus beta we have 1.13, AGO 768, FY 250, gamma MO 1.1. And if you calculate, I got this value 381.44 into 10 raised to 3 newtons, and which is equal to 381.44 kilonewtons. So it is single angle. Therefore, tensile strength, it is expected to write tensile strength of angle 100 by 8 is 381.44 kilonewtons. Then we have second question. We have second question in this, that is just a minute. We have now second question. I will again connect this. So I have to go to presentation and I have to check something happens. So now we have second question. So design a tension member. So design a tension member using double equal angle section back to back on opposite faces of 12 mm thick plate if it carries axial load of 320 kilonewtons. So we have connection in this fashion. So now we will go with AG required. So we have AG required equal to TU factorial load into gamma MO upon Fy. Now given load is axial load. So we have to multiply it by 1.5 into 320 into 10 raised to 3. This is most important. Into 1.1 divided by 250. And from this we get AG required value, that is equal to 2112 millimeter square. 2112 millimeter square. 2112 millimeter square. We require double angle. So area required for single angle equal to half of this 2112 upon 2, and it will be 1056 square. So select section. I have selected this section. Select angle 75, 75, 8 millimeter. You can go up to 10 because the thick gusset plate is given 12 but do not go for 12 or greater than 12 So select angle 75, 75, 8, and then we have area of this angle AG equal to 1140 square. Now we know tensile strength is minimum of tensile strength is minimum of. Now we have given only as we have welded connection, they have mentioned using welded connection. So we have two only. One is TDG and second is TDN. So now first we will go, that is tensile strain due to yielding of cross section. Yielding of cross section. And then we have formula TDG equal to AG Fy upon gamma m. Now AG we have double angle section. So 2 into 1140 into 250 and gamma MO is 1.1 and we will get this value, that is 518.19 kilonewton. Now value of TU if I will find on this side, so it is 1.5 into 320 and this comes 480 kilonewton. So now whatever we have provided, so this value is greater than 480 kilonewtons. Now then we have connection. So let we have this, we will consider as L1. We have this will be L2. We know. So we have CG of this section will be towards outstanding leg. And therefore this value is less compared to this value. We have this value 21.4 millimeter. 21.4 millimeter. So this is CG of this section. You can go to IS or steel table and you will get this value that will be connected to the leg. So now connection. So we have strength of weld. Strength of weld, and that is equal to zero point 0.7 S into Fu upon root 3 gamma mw. And then we have to put the values. So we have 0.76 weld we will consider. So zero point 0.7 into 6. Fu is 410 root 3 into 1.25. So you can write, assume 6 weld. And then from this, we will get this value that is equal to 795.36. 795.36 Newton per millimeter. And now we can take moment about L2, L10, then what we will get? Moment about L1 equal to 0. Then we have this force, we have 480 kilonewtons. So moment about L1 means we have to take about L1. So we have due to this force. So this value we have 795.36. into L2. This will be strength of weld. This is strength of weld per millimeter, and multiply by moment about L1. So this value, as we have taken angle section 75. So we have to take this value as 75. And then from this, we will get this will be so into 75, and that is equal to 480 into 10 raised to 3 into we have 75 minus 21.4. So just check the values. From this, I will get value of L2, that is equal to, just I will calculate, committed a mistake, 75 minus 21.4 divided by 790.36 divided by 75. So it comes actually 431.3 millimeters. So 4, no, sorry, this will L75, and this actually we have value of L1. So this is moment about L2, L. So this moment about L1, so we have to take it as actually 70, 21.4. 21.4, because about moment L1 and we have distance 21.4. So we have divided by 75 minus 21.4 into 21.4. So this value comes 172 point. I got 172.2 millimeters. Just check the calculations. And then for L1, just I will say something getting issue over here now. I have to check it actually. And then we have value of L2. So we will find value of L2 by considering, we can go to back page, and then you have this will be 795.36. Now into L1. Now we are taking moment about L2 into 75 equal to 480 into 10 raised to 3, and now it will be 75 minus 21.4, and from this we will get L1, that is equal to 431.3. What I got, just check it, 431.3 millimeters, and from this we will get actually Vs equal to W, which is 75 millimeters. Then we have T 8 millimeters. Then we have LC. It will be L1 plus L2 by 2. So we have 431.3 plus 172.2 by 2. And then we have this value equal to 431.3, 172.2, and we have 301.75. And then we can calculate TDN equal to zero point 0.9 ANC FU upon gamma ml plus beta AGOFY upon gamma ml. And then we can put ANC equal to AGO, because in welded section both are same. So B minus T by 2 into T. So 75 minus 8 by 2 into 8. And this value comes 568 mm square. And now beta we have to find, which will be 1.4 minus. Now I will directly put the values. W is 75, T is 8 in bracket 250 upon 410 in bracket. BS is 75 and this is 301.75 and I have this value. Just I will calculate because I have committed one mistake. Divided by 8 into 410 into 301.75 into minus 1 plus 1.4. So I got 1.29. So we have this value 1.29. And now we will put the value 0.9 ANC 568 FU 410 divided by 1.25 plus beta 1.29 568 into 250 upon 1.1. And then we have double angle section. So this will be multiplied by 2. So I will just calculate 568 into 410, 1.25 plus 1.29, 568 into 250, 1.1 into 2, 668.4 kilonewton, which is greater than 480 kilonewtons. Therefore, safe. And therefore provide angle to angle 75 8. So thank you. This will be about your first question, that is of unit test. Now we will stop here only. Thank you.